What's good, Year 11 General Mathematicians? Mr. Herman here with a brand new topic of investigating relationships between two numerical variables. Let's say values, but variables. Sorry for my webcam being a bit too bright. I can't be bothered putting the blind down behind me. I've got a puppy just sleeping to the side of me. I really don't want to wake her up. So you just kind of have to deal with this silhouette-y version of me. Well done on completing the previous chapter 6. A bit of a tricky topic towards the end, but hopefully you guys got there, especially with the condition of remote learning. That would have been a bit tricky to deal with this topic. So well done. Thank you for those who uploaded their work onto Compass or given their work to me via the Microsoft Teams chats. It makes my life so much easier when it comes to seeing if I can give you an S or an N, okay? So make sure you get on top of that. If you just stop submitting work without any heads up, just makes it tricky for me and it puts more work onto you. So I know circumstances are tricky, but just at least communicate one way or another. Tell me what's going on and I can be pretty lenient. But if you're just gonna not do anything, then you're gonna get it in. And I really don't like doing it, but in some circumstances, I've had to consider it. Okay, so be careful, guys. Just upload your work, do what you gotta do, and make sure that you can pass while doing remote learning. This topic here, investigating relationships between two numerical variables. Quite a bit of content to delve into it. But the biggest thing I want to highlight in this is the word relationships. Relationships, we think of both in math terms and non-math terms. Relationships, a form of being together, okay? Form being together, a link. And it's always a link between one and another. That's my interpretation of what a relationship is, okay? And we use relationships or links, or we discover these links within the maths world. And with the relationship, we can make judgments or predictions, okay? So we're dealing with data, of course. Okay, we're looking into data, and then from that data, we're looking at relationships between variables. Let's dive into this. Response and explanatory variables. So this whole chunk here, quite a bit to digest. Let's break this down. When we analyze bivariate data, I'm going to stop here. Bivariate, the bi here just means two. Okay, so bi, and I'm pretty sure it's Latin, just means two. And variate, think of something that varies. So we have data, and there's two forms of it that varies. Okay, think of that. That's bivariate data. We try to answer questions that have been proposed, such as, is there a relationship? Here's that word relationship popping up. Is there a relationship between these two variables? So the two things that varies. And more specifically, does knowing the value of one of these variables tell us anything about the value of the other variable? Tell us, and when we say tell us, this is just through prediction. So what we're saying is, let's say that we take 40 people and we survey them and we say, okay, we're going to ask you two questions. Each person, we're going to ask you two questions. First question we're going to say is, how many people are in your family currently living in one household? Okay, that can be one of the questions. And then the second question is, how many bedrooms do you have in your house? And that could be a second bedroom. That could be a second question. And so all these 40 different people are going to provide answers, okay? And this is bivariate data. This is bivariate because there's two questions that have been proposed. And the things that are proposed, the answers that they're going to give are varying, okay? Some people might say, I have 6 within the household and there are 4 bedrooms. Some might say we only have 3 in the household and there are 2 bedrooms. And we want to try to make an assumption or a link to see hey, is there a pattern going on here? The more people within the household, the more likely there will be more bedrooms. That's what this topic is about, okay? And we, of course, delve into different terminologies with this, okay? So, for example, I just gave my little preempt example, but for example, let's take as our two variables the mark a student obtained on a test. Okay, so you get a student, they give us a mark, so a score, maybe a percentage, and the amount of time they spent studying for that test. So it's the mark versus how much time they use to study. And it seems reasonable that the more time one spends studying, the better mark that they would achieve. That makes sense. More time, okay, in most of the time, okay. I do have students say, well, there are some tests where I just know the content and I don't study and I get a good score. Yes, that could be considered as a case, but generally speaking, the more time that you spend on a certain topic, the higher the mark, generally speaking. There are times where people spend a lot of time and their mark doesn't proportionally associate to that mark itself. Okay, those are considered one of those weird times that has happened before, but generally speaking, it's safe to assume that the more time you spend, the higher the mark. So for this reason, in statistics, we call the time that we spend the explanatory variable, okay? So let's break down what this means. Variable, because all the answers that we are giving about how much time students have spent, they vary, all right? They will change from answer to answer. And it's explanatory. Think of explanatory as an explanation, okay? One of them is going to explain the other, okay, in general forms. And since the mark may go up or down in response to how much time you spent studying, we call the mark, in this case, the response variable. It's almost like one is set as the cause and one is set as the reaction or response, okay? Reaction, there we go, there's a C there. So the time explains, generally speaking, what the mark could be. It can't be the other way around. If I told you, hey, this is my mark that I got for my test, you can't necessarily make a prediction about how much time they spent studying on that test. And you can guess. Chances are it's a bit too tricky for this to explain the other, but you can make an assumption that if they told you how much time they spent, comparatively speaking to all the other people that have provided time, you can say, okay, I can make an assumption that your mark will be this, okay? And that's what response and explanatory variables mean. So it's a lot to take in, okay? But I always just like to think of it as one is a cause and one is an effect or a reaction or a response. And this lesson 7a is going to be looking at determining the difference between one and the other and extracting which one is a response and which one is explanatory. And this green part here, when investigating associations or relationships between two variables, the explanatory variable, which we put as EV for short, is the variable we expect to explain or predict the value of the other one, or the response, the RV. One, the cause, will then explain the reaction or the response. The explanatory variable is sometimes called the independent variable. It's independent. And the response variable is called the dependent variable. And this, why we use these terminologies is that, say for instance, I said, hey, this is the mark that I got for one of my tests. That's dependent on how much time that it took to study for that. So the mark is dependent on some extra information, in this case the time. But the time that's being provided is just an independent variable. It's just a random variable that's been given. so it's considered as independent. I think it's old school terminology that they used to use independent and dependent, and it still pops up. To make it easy, we just use EV and RV for short. So let's have a look at these 3 examples, and we're going to try to identify the difference between explanatory and response. So it is important to be able to identify the difference before we start to explore the relationship between the 2 numerical variables. So obviously we're going to be analyzing different types of data sets, but we want to establish which one is explanatory and which one is the response. And once we know, or we can try to establish those 2, then it's easy for us to then approach the next set of skills, which we'll see in the next exercises. One way to help you decide is to put the variables in a sentence as follows. The mark, which is the response, RV, a student obtains is dependent on the amount of time they spent studying. It's dependent, so it relies on the amount of time. Okay, so just previously, as I was saying before, one depends on the other, hence independent and dependent. So example 1, let's have a look. Find the response variable and explanatory variable in the following situations. We wish to investigate the question, do older people sleep less? Do older people sleep less? The variables here in this case are the age and the time spent sleeping. So you can imagine that someone conducts a survey and they try to get a wide variety of people within the survey in regards to their age, so lower age and higher age. And then they ask, okay, what is your age and how often do you sleep? How often do you sleep? How long do you usually sleep for per night? Okay, on average. And these answers are provided, okay? But what we want to know is which one relies on the other one? Which one explains the response? Does the age determine how long people sleep for? Or does how long you sleep for determine your age? And you can see one of them doesn't work. The first one works, but the second one could, in some circumstances, work. But it's not something that you could rely on. So your explanatory variable in this case, the explanatory variable is your age. Because my age, I can make a prediction, and it's easy for me to make a prediction from all the results that I get, that my age can help me predict time spent sleeping. Time spent sleeping. So this explains this. The age can explain how much time I spent sleeping based on the data that I get, and I can make predictions on this. And if I were to get this data, and we will be seeing this, and I map it out on a graph, and I put age here and time spent sleeping here, you can make a prediction maybe that the younger you are, the longer it takes for you to sleep. And then as you get older, maybe this tends to die down, or maybe it goes from start to finish, maybe it goes the other way, we don't know. But we can say that your age can definitely predict your time spent sleeping. The second question, we wish to investigate the relationship between kilojoule consumption and weight loss. The variables in this investigation are kilojoules of consumption and the weight loss. So literally what entails within the question here. Now we want to know which one explains the other. Does the kilojoule consumption explain the amount of weight you have lost? Or does the amount of weight that you have lost tell you what your kilojoule consumption is? Now this one is a tricky one, okay, because it's likely to think that it can work both ways, that they can intertwine with each other. Again, you can just, it's one of those irreversible ones. But in this case, if I were to tell you, hey, this is my kilojoule consumption, this is how much I've been eating, and then I told you how much weight I've lost based on that, or maybe even gained. It works in that way, but you can't necessarily determine weight loss. If I told you, you can't determine, the kilojoule consumption if I told you how much weight I lost. Oh my goodness, that was a bit of a tongue twister, okay? So in other words, this one here is your EV. The kilojoule consumption is the explanatory variable. Kilojoule consumption. Meaning the response variable is your weight loss. How much weight has been lost? And finally, last question. Can we predict people's height from their wrist circumference? The variable in this investigation are height and wrist circumference. Now there's a bit of a hack in this. When a question has been given to you and has the word from, you can automatically determine what your explanatory variable is, okay, without a doubt. Can we predict people's height from their wrist circumference? Meaning the explanatory variable has to be the wrist circumference. It's coming from this. Can one determine the other? From this, we can say that the wrist circumference is the explanatory variable. It has to be. Okay, so the response is the height. The response is the height. And think about it this way: someone has a small wrist, you can say, oh, yeah, they're quite short. And then someone has a bigger wrist, you can say, yeah, they're tall. But you can't necessarily determine the height of someone. You can't determine the wrist circumference of someone if given their height. Okay. Now, again, another one of these ones seems like they work and they're irreversible, but this is not the case, especially when the question specifically says from. Now, a lot to take in, okay? There is a lot of information between the difference between the two. You will get within your log sheet that you only have to do question 1, but also, I'll just pop it up here. You will also be getting this sheet that is attached to lesson 1, and you're just identifying the difference between EV and RV for these, I think it's 18? Yeah, 18 questions. The first 10 are pretty much giving you what the variables are, but then afterwards, you have to extract which one is the EV and which one is the RV based on the context. Okay, so we're kind of jumping into the deep end with this topic, okay, because there's a lot of analyzing and extracting information. The math side behind it, not necessarily there yet. Okay, it's more defining EV and RV and getting the hang of that. Now don't worry, the solutions to this will be attached to this document, but try not to just rely on this. Okay, this is a skill set that I really want you guys to get the hang of and be able to just determine the difference between the two. So maybe put an approach in trying to tackle these questions, then refer to the answers to make sure that you are doing them correct. Okay, and that concludes EV and RV. Check your log sheet to see which question you have to do, which is question 1 anyways, I already told you. And I'll see you guys in the next video. Ta-ta!